Right now, once and for all, we are going to squash your fears of that pesky little topic that is electrolysis. And make sure you're paying extra close attention because after researching the past years of exams, this is one of the practicals we think is going to come up on Chemistry Paper 1 this year. Let's first break that word down, electrolysis. Electro suggests we're using electricity, and lysis is the fancy science word to mean splitting. So electrolysis is using electricity to separate or split an ionic compound. Quite simply, the whole process just involves us chucking these two rod things into a liquid, and those rods are called electrodes, and then passing current through them to separate the ions that that liquid contains. Passing that current through the electrodes causes one of them to become positive and one of them to become negative, and therefore the ions within the liquid carrying the opposite charge to the electrodes will be attracted to them as opposite charges attract. And it's that fundamental fact that allows electrolysis to work, because ionic compounds always contain both positive and negative ions. Another fundamental and common question that comes up with electrolysis is about the electrolyte itself. Now that fancy word just means the ionic compound either molten or dissolved, basically mixed with water. It is absolutely vital that our electrolyte remains in liquid form, because if not, the ions, say in solid form, would have been fixed in position and not free to move. This whole process relies on the ions being able to be attracted and then moved to the oppositely charged electrodes. So they must always be, the electrolyte must always be in liquid form, either molten or dissolved. Now remember, we talked about those electrodes, you get both a positive and a negative one. They have a special name. The positive one is called the anode, and I remember that thinking A for add, and then the negative one is called your cathode. The positive electrode, which is the anode, will always attract the negatively charged ions, and those are always the non-metal ions, since non-metals will always gain negative electrons when they form their ions. The negative electrode is your cathode, and since it's negative, it will always attract the positive ions in the solution, and those positive ions will always be your metal ions, since metals will always lose negative electrons when they form their ions. Next thing to worry about, and where most students get lost, is when we talk about products of electrolysis, and that comes down to whether what you're electrolyzing is molten or whether it's dissolved. We'll start with molten. If the electrolyte is molten, that kind of means that by definition we had the pure ionic substance heated at uploads until it melted and became a liquid. Because of that, there are only two ions present in the solution, the metal ion and the non-metal ion of that original ionic compound. And because of that, there's only one thing that can be produced at each of your electrodes. The non-metal thing will be produced at your anode, and your metal thing will be produced at your cathode. Now here's where it gets a bit spicy, because if you have an aqueous solution, not only do you have the metal and non-metal ions from your ionic compound, but you've mixed it with water, and that water will dissociate to give you H+ ions and hydroxide ions.